Hello everyone and welcome to this week's Lightweight Java Game Library 3D game tutorial, and this week we're going to be rendering a quad using vertex array objects and vertex buffer objects. Vertex array objects are the modern way of storing and rendering models in OpenGL, no more of the old display lists or any of the old immediate mode stuff. But what are vertex array objects? A vertex array object, or VAO as I'm going to call them, is an object in which you can store data about a 3D model. The VAO has a load of slots in which you can store data, and these slots are known as attribute lists. And I think that a VAO usually has around 16 attribute lists, but don't quote me on that. We're not going to need anything like that many anyway. But usually you store different sets of data into these different attribute lists. So in one you might store all the vertex positions, in another you could store all the colors of all the vertices, or the normal vector at each vertex, or the texture coordinates at each vertex, or whatever you want really. It's up to you what data you store where. And these data sets are stored in the attribute lists as vertex buffer objects, or VBOs. So what's a VBO? This is very simple. A VBO is just data. You can see it as pretty much just an array of numbers. Very simple. And this data could be anything. It could be positions, colors, normals, or whatever. And each VBO can be put into a separate attribute list in the VAO. So that's how data is stored, but how do we access this data whenever we need it? Each VAO has a unique ID, so when the VAO is stored off in memory, we can access it at any time using its ID. But how exactly do we represent a 3D model as a load of data that we could store in a VAO? Well, every single 3D model that we're going to be dealing with is made out of a number of triangles, and each of these triangles has of course 3 vertices, 3 points in 3-dimensional space. So each vertex has a 3D coordinate, an X, Y and a Z, and if we take the coordinates of each of the 3 vertices of the triangle and then all of the coordinates from the other triangles in the model, we'll have a list of data that represents all the vertex positions of the model. And it's this sort of data that we can put into the VBO and store into an attribute list of a VAO. And that's what we're going to be doing in this episode. We're going to be rendering the simplest of 3D models, a rectangle, which is made of just 2 triangles. And we're going to be taking the vertex positional data of those triangles, creating a VBO, storing the data into the VBO, creating a VAO, storing the VBO data into one of the attribute lists of the VAO, and then we'll use the ID of the VAO to tell OpenGL to render the VAO rectangle VAO whenever we desire. Let's get coding. So let's continue from where we were last time. You should still have your display working nicely, and if you have, you can go ahead and create a new class called RoleModel, and this class is going to represent a 3D model stored in memory. And there's 2 things we need to know about a model once it's stored in memory. We need to know its ID of the VAO, and we need to know how many vertices are in that 3D model. And we're going to create a constructor here which obviously takes in the ID of the VAO that the model is stored in, and also the count of the vertices, so how many vertices there are in that model. Just a simple constructor here. And we also need some get methods, so we're going to generate getters here. Just select getters and press OK, and that's the RoleModel class done. So let's move on to the next class, and this class is going to deal with loading 3D models into memory by storing positional data about the model in a VAO. So I'll create a class called loader, and we're going to create a method that will take in positions of the model's vertices, load this data into a VAO, and then return information about the VAO as a RoleModel object. And there's 3 steps that we need to take to carry out this method. The first thing we need to do is to create a new empty VAO, and we're going to create a method here that's going to do that, and this method will return the ID of the VAO that we create. Then we're going to need to store the data into one of the attribute lists of the VAO, so we'll have a method for that which will take in the number of the attribute list in which we want to store the data, and also the data itself. And the final thing that we need to do is to have a method that unbinds the VAO. When you've finished using a VAO, you have to unbind it, and I'll explain it a bit more later. So let's go back to this first method here, and let's lay out what we're going to do here. So the first thing we're going to do is to create that empty VAO and to get the ID of it, and we'll store the ID in a variable called VAO ID. Then we're going to store the positional data into one of the attribute lists of the VAO, and we're going to store it into the attribute list 0. No particular reason, but it is the first attribute list, so why not? And then, now that we've finished using the VAO, we will unbind it and then return the data that we've created, the information about the VAO, as a raw model. So that's going to take in the VAO ID, and it also needs to know the number of vertices of the model. So that's going to be positions.length, and we're going to divide that by 3 because of course each vertex has 3 floats, an x, y and a z. So let's start work on this first method here, the create VAO method. And first thing we have to do is to actually create that empty VAO, and we can do this by calling the method gl30.glgenVertexArrays, and this will create an empty VAO and return the ID of that VAO. We then need to activate this VAO. If we want to do anything to it, we have to activate it by binding it. So we call glBindVertexArray and we put the ID of the VAO that we want to bind, and we're going to return that ID as well from this method. And the vertex array object will stay bound until we unbind it, which is what we're going to do in this method here. And we can do that by calling that same method glBindVertexArray, and instead of putting an ID in here, we just put 0, and that will unbind the currently bound VAO. So let's move on to storing data into one of the attribute lists. Firstly, as I said earlier, we have to store the data into the attribute lists as a VBO. So let's create ourselves an empty VBO by calling glGenBuffers, and that will return the ID of the VBO that we've created. Now we need to bind the buffer because, as I said, same with the VAOs, if you want to do something to a VBO you have to bind it first. And here we have to specify the type of VBO, and it's going to be a GL array buffer. And then we have to put the ID of the VBO that we want to bind. So now that it's bound, we can store data into it. And data has to be stored into a VBO as a float buffer. So I'm going to create a method down here that's going to convert our float array of data into a float buffer. So let's just call this store data in float buffer, and it will take in the float array that we want to convert to a float buffer. And the first thing we have to do is to create ourselves an empty float buffer simply by calling bufferutils.createFloatBuffer, and it needs the size of the data, which is pretty simple. And so let's go ahead and import this. Then we're going to put the data into the float buffer, which is as simple as it possibly could be. Buffer.putData. Then we need to prepare the buffer to be read from, because at the moment it's expecting to be written to, but if we do buffer.flip, it knows that we've finished writing to it and it's preparing to be read from. And then we'll return that buffer so that we can use it to store into the VBO. So let's go ahead and call that method now and convert our data into a float buffer. So once we've got a float buffer with our data in it, we can store it into the VBO. So let's go ahead and do that, and we do that by calling glBufferData. First of all, we have to again specify the type of VBO, which again is a GL array buffer. Then we put the data in, and then we need to go ahead and specify what the data is going to be used for, whether it's static data or whether we're going to edit it once we've stored it. And we're not going to edit it ever again, so we can just call it GL static draw, so that OpenGL knows that we never want to edit the data once it's stored in the VBO. And now we're going to go ahead and put that VBO into the VAO, into one of the attribute lists. And we do this by calling glVertexAttribPointer, and this takes in a whole load of arguments, which I'll explain now. So the first attribute, the first argument that it takes in is the number of the attribute list in which you want to store the data, and that's just going to be attribute number. Then it wants to know the length of each vertex, which is 3 because they're 3D vectors, an x, y and a z. Then it needs to know the type of data, it's just a float. Then it needs to know if your data is normalized, and ours isn't, so we put false. Then it needs to know the distance between each of your vertices. Have you got any other data between them? And we haven't, so 0. And finally, the offset. Should it start at the beginning of the data? Yes, it should, so we'll put a 0 there. And then finally, because we've finished using the VBO, we can unbind it, and we do this the same way as with the VAO. We just call the bind buffer. Again, we have to specify the type of VBO, which once again is GL array buffer. And then instead of putting an ID in here, we just put 0, which will unbind the current VBO. So that's it. That's how you store data into a VAO. There's one more thing we have to do in this class, a bit of memory management. At the end, when we close down the game, we're going to want to delete all the VAOs and the VBOs that we've created in memory. So I'm just going to declare a couple of lists up the top here, and they're going to keep track of all the VAOs and VBOs that we create. So let's just import these, and then we're going to go into the code here, and whenever we create a VAO, we're going to add it to the VAO list so that we can delete them later. And the same with the VBOs. As soon as a VBO is created, we will store its ID in the VBO list. And then when we close down the game, we want to call a method that will delete all of the VAOs and VBOs in these lists. So let's create a method called cleanup, and this is just going to loop through both of these lists and delete all of the buffers and VAOs in them. So first, for every VAO in the VAO list, we want to delete it. So we can do that by calling GL delete vertex arrays and put the ID of the VAO in there. And pretty much exactly the same for the VBOs, except this time we call GL delete buffers and we put the ID of the VBO in there. And that's it. That's the loader class pretty much done. So now that we're able to load a model into a VAO, we need to create a class that can render the model from the VAO. So let's create a class called renderer, and the first method that we need to put in here is a method called prepare, and we're going to call this once every frame, and it will just prepare OpenGL to render the game. And all we need to do at the moment in this method is to clear the color from the last frame, and we can do this by doing GL clear color, and then we choose the color of the background that we want, with 1 being the maximum for each of these for the RGB values. So I've gone for a red background there. Then we need to actually make the method that will render a raw model, and this method will take in the raw model that we want to render. And this isn't too tricky, it's a lot easier than loading up into a VAO. First thing we need to do is we need to bind the VAO that we want to use. As I've said, if you ever want to do something to a VAO, you have to bind it, and we have to put in the ID of the VAO that we want to bind, and that of course we've got in the model. We then need to activate the attribute list in which our data is stored. So we enable the vertex attribute array, and if you remember, we put our data in the attribute list 0, so that's the attribute list that we're enabling. And then we're going to go ahead and render it, and we're going to use the method GLDrawArrays. First, it needs to know what we want to render. We want to render triangles, so let's put GL triangles here. Then it wants to know where in the data it should start rendering from, and we want it to start at the beginning. And it also needs to know how many vertices it should render, which we have that number in the model. And then we've finished using everything, so we need to disable that attribute list, that 0th attribute list, and we also need to unbind the VAO, which we know how to do now. It's just GL bind vertex array, and instead of putting an ID in here, we put 0. And that's the rendering class done. So let's quickly go to the main loop and very quickly put all this together and see if we can render a quad. So let's create a loader object so that we can use the methods from the loader class, and let's do the same with the renderer so we can use all those methods that we just created. and import both of those. And we also have to remember to clean up the loader once the game has closed, to delete all the VBOs and VAOs that we've created. Also, as I mentioned, we have to prepare the renderer every single frame, so let's call that method. And now all we need is the list of vertices for the quad that we want to render, and I've actually got them copied here, so you can just copy them this week. I'll explain more about how I got those vertices next week, but for now just copy them. And we're going to load that up into a RoleModel using that load to VAO method that we had that we created earlier. And now that we've got that RoleModel, we can render it using the method in the renderer, which is render. And we put the model in there as the argument, and we can run that now, and there you go, we've got a quad rendered onto the screen. So that's it for this week. Next week we're going to be looking at the OpenGL coordinate system and also learning about a more efficient way to render models. If you'd like to see a game that I've made using the Lightweight Java game library, then you could also check out my game development log videos. I upload one every week about the 3D Java game that I'm currently making, so you can check that out if you're interested. But yeah, thank you guys very much for watching this video. Do subscribe if you haven't already. Have a brilliant week, and I will see you all next time.